Okay, this is the RF radio frequency doubler that I built using the toner transfer method, designed on the PC. Express PCB, I think the program is fairly easy to use. Anyway, so what we've got here, it's powered up at the moment, and we're injecting 13.8 megahertz in, no modulation, at about 300 millivolts from the Hewlett Packard. So that's being injected into the input here, and we're monitoring it on the frequency counter, 13.8 megahertz, spot on, lovely. So what we'll do then is we take the connector for the counter, and now we'll connect it to the output, and we have 27.6 megahertz. So it's double the frequency. Now, how does it work? Well, I'll explain in very layman's terms. Anyone in the know is going to start coming back at me saying about harmonics, resonant frequencies, blah, 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 blah. I'm not trying to do that. I'm just trying to explain roughly a very basic way it works. What you have, if you have a bell which is ringing at 1 kilohertz and you hit it with a hammer, it will ring at 1 kilohertz. If you hit it with that hammer 1,000 times a second, it's still going to ring at 1 kilohertz. You'll never change that because that's tuned to that frequency. So what we've got is 13 megahertz in. This is amplified by this little transistor here. We've got about 300 millivolts in. This is amplified to about 1.5 volts into the first coil. First coil is a hammer. Okay, so this is running at 13 megahertz, 1,000 millivolts, 1,500 millivolts. This is then driven into the second transformer, which is tuned to 26 megahertz, 13, 26, 13.8, 27.6, whatever. So this rings this tuned circuit at a high voltage or a higher voltage in the input. This then resonates at double the frequency because it's tuned to double the frequency. The output is lower because you get losses. There's inherent losses doing it this way. But that's basically how it works. You've got a frequency in which is amplified into a big hammer, which then hits the bell and resonates to the frequency that you want. That's basically it. I know a lot of people probably won't be very interested, but I found it quite an interesting exercise. Cheers.